let's start now. Hello everyone. This is John from New Smart Economy. Uh, Today we are glad to invite Eric and his partner to join our second workshop. Today's workshop is to writing Python smart contracts. I think firstly, let me invite Eric and his partner to introduce themselves. Hi, Eric.
Hi, thanks for the introduction. Want me to take over from here, or
Yeah,
do you want to?
you can. I think you
Okay,
can introduce yourself first, and then you can start.
sure. So, who are we? We are actually there's two of us in this workshop. So first off, there's Marella, and she's a software developer at COZ, and she's actually the author of BOA, the compiler. And then there's me, Eric. I am also a software developer at COZ. For me, I've been here since 2017, just like COZ. I joined pretty early. Marella, I'm not sure actually, was it 2018 that you joined? 2019?
2019.
2019. Okay, so we both work for a group called COZ. We used to be called more City of Zion. So that's where you will see that name you will see in our GitHub profile. And just to give a little bit of background to some of the projects that you might know of us, or you might not know that it was us or is us. Well, we have BOA, that's a compiler. We have Dora, that's a block explorer. We created the Ledger app. We have Mamba, which is another Python SDK, more on the off-chain side. Neon.js, the TypeScript SDK. We have a mobile wallet and desktop wallet, a Wallet Connect SDK, and yeah, a bunch of other projects. But since this workshop is about Python, let's get into that part. A little agenda. I want to start out with to make sure that everybody is aligned on smart contracts, where they live, and then I will discuss what is BOA and what is it not. Then, and after that, we're going straight into smart contract examples. And the way this is going to work is I actually, instead of building up a smart contract from minimal all to a full-fledged, I actually want to address individual features. So you have building blocks and keep the information contained. And from there, you have building blocks to create your own. At the end, I will show you like a GitHub repo for BOA, which contains full-fledged examples for tokens, ICOs, and a whole bunch of other stuff. So definitely have a look over there afterwards. I will share the presentation in the end, so no need to write down any links that you might see flashing by on the slides, because well, you get the presentation, you can simply click on them. So the stuff that we're gonna, and then I'll end up with what I would say is the recommended development flow after all the contract examples, and then a couple of other tools that might help you in your contract development journey. So first off, a mini introduction. What are smart contracts? And the reason I'm doing this is because historically on the Discord channel, I've seen some people ask questions and it looked like they had a misunderstanding of where the contracts actually live and what a contract actually is. So basically, we have a contract written in, well, in our case, it's going to be Python. It will be compiled to a different format, in this case called a NEF, which stands for Neo Executable Format, and then it will be deployed onto the blockchain. And kind of way you can look at this is like a couple of endpoints in the cloud, right? So a smart contract can have one or more public functions, and you can call this over the network, and you can get a result from this, or it will create a state change on the blockchain. Now, these smart contracts can have storage, and to persist data. We will get a little bit more into that later. So this is just to make sure everybody knows. Hopefully this is clear. If you have a question about this, please let us know now, because otherwise we might be in a little bit of trouble later on. So if there are no questions, I am going to continue. Oh, no questions. Good. Okay, so BOA capabilities and limitation. So like I already said on the previous slide, BOA can compile Python code into Neo blockchain compatible code or smart contracts. The tool is cross-platform, so you can use it in Windows, Linux, Mac, because it's written in Python. It has some test facilities, and I will get back into that later. But there are also some limitations because it is translated to the Neo blockchain. Not everything works like your regular Python. So one of the things, it does not support floats. And the reason for this is because the Neo blockchain doesn't support floats. So if you want to work with floats, use a multiplier and a divider, and you should be able to get the same behavior. In order to help correct translation to the Neo blockchain format, we require type annotations. That's a choice made, so just be aware of this. The other thing is it doesn't support native extensions. Like, so extensions written in C are not supported for, well, I hope by now obvious reasons. They are written in C and they need to be translated. And correct me here if I'm wrong, Mirella, but the way BOA works, it reads and creates an abstract syntax tree, and from there it translates. And I don't think this shows up in that tree, does it? That you know?
I'm not sure if it does, but probably doesn't.
No, so I mean, there are many. I'm pretty sure that it doesn't work because the C code remains C, and obviously, well, the underlying system of Python is still in C. But do not fear. A lot of other features still work. You can create modules, packages, classes, all that kind of stuff. And I think as long as it's written in pure Python, you can even import third-party packages. So this should all be good. But it is good to know that BOA is actually a subset of Python. That also means that not everything is supported yet. So we have a lot of things that are supported, but the first thing that comes to mind that is not yet supported, for example, are lambda functions. However, we support list comprehensions. So as long as you, another thing is custom decorators for functions, I believe is not yet supported. So if you run into anything that doesn't work, please let us know on GitHub so we can see the demand for a certain feature, and then we can put that on our list to work on, or put it higher on our list to work on. So having said that, let's jump into installation. Installation is fairly straightforward. BOA is available on PyPy, so you can just pip install the tool, or you can get it from source at the link shown here. Now, BOA is a command line tool, and the only current feature or command that you can run is compile. So you type new3 BOA compile, and you give it the entry file to compile, and it will take all the imports from packages and whatever you use, and will create a nice Neo executable format for you. So let's look at a minimal smart contract. I have prepared some, let me hide this, prepared some work. Smart contracts just look, basically, we just have functions, whatever we want. I mean, the entry point is always a function. So in this case, we have a function called main. And the way to make this function accessible from the outside and like a public API, is we add a special decorator called public. From that point on, the function can be called, and in this case, it's not a very useful smart contract, but it says hello world. This shows up in the logs. Most of the stuff from BOA you will get from here. Then there's different packages. We will not cover all of them, but this is the place you want to go if you want to explore features that have not been covered. So let's just see, or let's just compile a contract so we can see what happens. So on the command line, there's an E3 BOA, compile, and then we press enter. And what we will see is it wrote an NEF file into the same directory. And if we then show the files, we actually see 3 files. So one is our source file, one is the compiled code, and then there is a manifest. And in this manifest, let's say these 2 files are necessary to send to the blockchain. Things covered in there are like, what is the name of your contract? What kind of permissions? What is the description of what the contract does? An email, and we will show you later on how to set this, because this is automatically generated. You can set permissions, stuff like it is not allowed to call any other contracts, or it's only allowed to call a certain contract. So let's move on, since this is not a very, so this is pretty much the basic contract, the bare minimum that you can do. Each contract must have at least one public function. If you don't have a public function, it will not compile, just so you know. So if you set it all up and you're missing the public annotation and it fails, have a look. Probably, actually, I don't know what the error message will be. Let's have a look, actually. Let's see what it says. Empty script was generated. So that's the message that you will get if you have no public functions. Let's go to the next one. So this is not very useful. What we actually want to use often is storage. For example, you want to track the balance of a, say you're a token, you want to track the balance of a certain account. Storage on smart contracts are key value pairs. So there are special functions for this. We have a put, which takes a key and a value, a get based on a key and returns a value, a delete by key, and then a special one called find. We will get to the find in a minute. Let's first look how the basics ones look. Let me go to my own editor. So I'm actually a PyCharm user, but I will show a feature that's currently only available in VS Code soon. So here's an example on using storage. We add an import from the interop package called storage. So we have a function called store and retrieve. So if we want to call this function, this is the exact name you currently have to call. So we added a public annotation, it's available. It takes a value, and then we put it under a key, under this value, and to return it, we call storage get. And we ask the key, and that should return the value. Now, let's compile this. There too. And we get an error. Expected type string got bytes instead. So everything returned from storage is bytes. Even though, for example, if I would store an integer, it is your responsibility to convert it back. Because, well, my IDE kind of gave the warning already. If I hover it over, it says the same issue here. So what good to know, there's an error, there's a line and a column here. So it's line 8 over here. So let's convert this to a string, compile it, and now it works. So I'm going to show you a very useful tool, which I highly recommend for anyone developing. There is a debugger support also for contracts written in Python. Now, the first thing to do is we need to generate debug information. So there's an extra flag called -db. If we run this and we say, right, like this, we see a new file called the debug info. So this file is important for the debugger to give you line-by-line debugging. So there's this, let's see, I will actually show you a launch file. So there's a plugin called Neo Debugger. I will give you a link at the end of the presentation, which you can install, and then you can actually run contracts. So for example, here is the storage contract that we're gonna run. A bunch of this stuff is all the same. I think the most important one here is the program, which you point at the NEF file. And then here we have the operation. In this called the name of the method, store and retrieve. And the argument that we send is going to be my value. If I press play here, by default, it will break on the first line. So here you will see, if you look on the left side, we see the storage is currently empty. Nothing is here. But if we step over, we see a new value added here. Now this number is not very convenient. An issue exists to change this. The code is actually already there. It just needs to be merged. So just be aware, this is I believe it's a hash of the actual key. But if we unfold it, we see there's a key and a value. So the key that I used was 01, which you see here, and the value is also 01. Oh wait, that is not good. I wanted to show you with it should be a value. So 1 second, I am going to recompile this because I want to show you another trick. So let's run this again. We put it to storage. We look at the storage, and I will see an item with a bunch of bytes. Now I happen to know that this is my value, but this is not really easy to read. So what you can do is you can add it to the watch list. Double click here, and you can cast it to a string. And I need to make my screen a bit larger, but now you can see it actually displays as my value. So this is just one of those tricks that is nice to know. If we continue the debugging session, we press play. At the bottom, we will see that the value that was returned is my value and a gas consumption of 0.03. Let me run this one more time, because you can also inspect, well, in this case, you can see you can inspect variables, you can put breakpoints if you want to. So this is really, this is, I would say almost as good as it gets in debugging your smart contract. I mean, same thing here. Sure, there's probably some features still missing. Please report them. The more people are raising their voice, the better we know what to address first. This is not a tool created by COZ, by the way. This is a tool by NGD Seattle, NGD Enterprise are they called now. Harry DevHawk on Discord is the main guy behind this. And yeah, this is just gonna make your life a lot easier. So these are the basic storage functions, but let's go back here. We have another one called find. And find, it can be very useful. For example, if you want to retrieve all accounts, whatever. Basically, it takes a needle, like a prefix that you search for, and it will return all results. It returns a special class called an iterator. not the same iterator as regular Python, but it's an actual class and has a function next with a value. And you can also give it a couple of options to filter your results. So let's have a look at what that looks like. So do a little bit more here. Again, so we have the storage input. We have a new one, which are find options, which we will address in a bit. So this contract, basically, we store two keys, both with the same prefix. And let's just imagine that this is an identifier for an account. And I know that this is a value, this could be balance or something like that. If we want to retrieve all balance values, we would use a storage find. We can say, just use the prefix. And for the options, we say values only. By default, it will return key value pairs. Key value pairs, including this prefix. So it would return prefix account is defined as FF. So it would return FF01 as a key and then AA as the value. There are other options. For example, keys only. Keys only includes still the prefix. If you want to remove this prefix, for example, you want to go through your list and say, and you know that these are account numbers, something like that, and you only want to get your account numbers. You can do that. You can do something like this. You say keys only, because it's a flag, and you can say remove prefix, and this will give you only this part, right? And so the reason why this is useful is storage has a price. The larger your storage, the more you have to pay. So you kind of want to be smart in how you. I mean, you could have made like the easy solution is just make another table, or what do you want to call it, another list that you store with all the accounts. But that is going to cost you. And in this way, you can kind of combine storage in one go and filter out the parts that you want. So what it returns, this is an iterator class, as said before, and the current way to go through the results is like you ask next on the class, and then to access the value, you say iterator.value. Just to know, we have an issue open to add the iterator protocol support to this class. So instead of writing the above, you could say for the value in iterator, and then do your result results. And that, of course, feels much more Pythonic. This isn't included yet, but it is something on the list to look out for in the future. So those are the basics of storage. Let's go back here. Now, storage alone is great. You can already do a lot more. But if you store your balances, for example, you have your custom token, and if you store balances in storage, you kind of do not want others to be able to modify your balance, right? So what we want a way to restrict access to functions. And for that, we have a special function, or there's a special function on the blockchain that can help you with validation of or authentication, kind of how you want to look at it. And this function is called CheckWitness. And basically, so in order to change state on the chain, you have to send a transaction. Now, this transaction, let's take a token transfer as an example. In order for this token transfer to only happen, how to say, you don't want somebody else to be able to transfer tokens from your account. So the way to prevent this is you sign this transaction, right? And this signature kind of proves like, hey, this transaction says it's want to send, I don't know, 10 NEO from my account to another person. And here's my signature of approval that I agree with what this transaction is trying to do. So there's a signer for this and a witness, a combination pair. And basically this function makes sure that this approval exists on the transaction that is trying to invoke your function. Now this might sound a little bit hard. So let's have a look at the code, because we don't need to know all the internal details actually. So for example, this hopefully makes it a bit easier. So let's say this is your contract, and we have defined the owner of this contract is a certain script hash. That can be the script hash of your wallet account. And there is a function that should only be called by whoever is the admin or the owner of this contract. So the check is very simple. We say if CheckWitness is the owner, we grant them access. They can do whatever they want. If not, we say access denied and nothing happens. So the CheckWitness function, if you look at the top, there's an import from the interop layer in the runtime. It's called CheckWitness. It's pretty straightforward to use. Now the thing is, and this goes far beyond the scope of this workshop. Neos, there's a lot of flexibility in where this signature is valid. Neo has a lot of options, like far more options than other blockchains, in allowing you to control the scope of this signature. For example, say you give permission to transfer funds from contract A, but contract A also calls another contract. Now you want to make sure that contract B is not allowed to transfer any funds. And one of the ways to do this is to, so this is slightly off topic because this is more on the calling side, but one of the ways to do this is to add a scope which says it is only allowed to be valid in the first contract it calls, which is called by entry. But you can also have a signature that is valid in the whole scope. Or there's a special feature called witness rules, and you can have like and conditions or conditions. But the topic is so big, I mean, you could probably fill a 1-hour workshop with it. So we're not going to do that. Instead, I added this link. So our friends at NSPCC, they wrote an article on Medium with nice pictures that explain to you what each scope means, where it is valid, that kind of stuff. And yeah, I highly recommend reading it because it's a great way of securing your transactions, but also your contract, because you can filter out permissions. I mean, you can say, I only want a certain group of accounts to be allowed instead of this single owner that we used in the example. So that is access. You can do your own thing, obviously. I would say, please use this and don't get scammed, because it is hard to do right, and you better use what is built in than trying to roll your own way of checking, because that's what it's for. Next, whatever product or contract you might create, you might want to accept payment tokens. NEO has 2 special functions for this, and they are called on NEP 11 payment and on NEP 17. So NEP 11 is for the NFTs, and NEP 17 is for your regular tokens. They have a predefined or expected behavior, which is actually defined here in the, can I click this? One moment, let me open this in a window so you can follow along. Proposals. So here on Neo's GitHub, there's a proposals repository which lists these standards. Let's take the NEP 17 standard. So there's a bunch of methods that it expects to be implemented, to be compatible. And then, where's the event? There's an NEP 17 payment event with a bunch of rules on what it should do. Now, we have an example, and I can now actually also show you where the code is, or the full-fledged examples. So in the City of Zion, that's our repo or repository organization. We have the need3 BOA repo. If we go into BOA test examples, there is a full-fledged NEP 17 example with all its features, which I'm not going to describe now, but there is a NEP 17 implementation that you can use as a reference. Now there's some new stuff in here. So let's go to my version. So a couple of things new that you will see in this contract. So for example, I called my function on NEP 17 payment with underscores because that's the more Pythonic way of writing it. But the standard expect that the name equals on NEP 17 payment. So this public decorator, as a couple of arguments, this allows you to change the external name. So the name that needs to be called when interacting with the blockchain. So this is a way to rename, but you can keep the internal way if you like. For example, if your linter isn't happy with, if you have a very strict linter with the way you name your methods, this save is an extra feature of securing. So basically, if you annotate your function with save set to true, that means that this function is allowed to make changes to your storage. So in this case, save is false because if we accept payment, and we might want to, actually in this case, we could have set it to true because the contract doesn't really do anything. But for example, say you have a transfer function that modifies storage, this save has to be false. I believe the default is actually false. No, the default is true, so that is good to know. So anything that's changing storage, make sure to set save to false or it will fail. Now, this example shows you a contract which only accepts gas. So we do a check here on the calling script hash. So the way transfer works, for example, of Neo, is a user will call, in this case, the gas contract. The gas contract does the token modification or the balance modifications. So it updates the destination balance, it subtracts the amount from the source balance, and then as final step, it will call this function on the destination if the destination address is a smart contract. So what we can then do is, and this is a special, let's call it a type, for lack of a better word I can come up with. So here we know, so a calling script hash, so this is actually the contract that is calling us right now. So basically the check says here, if the source that is calling us, that script hash equals gas, then we accept it. Otherwise we abort and we roll back the whole transaction. If I, as a user, would directly try to call this on NEP 17 payment, then the calling script hash would be that of my wallet account. So that's kind of how this works. We have a similar signature for NEP 11. please have a look at one of the examples. The behavior is very similar. I think it has, from the top of my head, an additional argument for the token ID or something like that. So that is accepting payments. Oh, and maybe one probably related to accepting payments is, what if you want to extract payments from your smart contract? Say you have an ICO and people send you NEO or gas, and in return you gave them your token, but now you want to extract the NEO from your smart contract to your own wallet, something like that. There is a, what was it called? I'm trying to remember. Yeah, this one. There's an executing script hash. Actually, you know what? I'm gonna skip this for a moment because I first want to show you how you can actually call another contract, and then we will cover this this example. So this is about receiving payment. How are we time-wise? Time flies. Calling other contracts. So you are not limited to, like, or your smart contract can use other contracts. Say for whatever reason there is a contract that has a function that you would like to use, or even the example that I tried to explain just now is you want to send NEO to your own wallet. So there's two ways of doing this. There's a function called call contract, and there is a function, a way to wrap a clause and make it easier. So let's just have a look at both of them. So the nice thing is, if I had known, if I had run this before, this example would probably look like, oh, now we're going to transfer NEO back or gas back from a smart contract. But since this is the first run, the returning funds just came up in me. So we're just going to use this example. So we have a public function called calling contract one. This is the destination hash. And so there is a special function called call contract, which is imported from the interrupt contract. And it takes a contract hash and a method to call. Now what you will see is the call contract signature as a return type of any, because, well, it kind of has to be generic. But our function returns a string. And in order to make BOA happy, we need to cast this to a string. If we do not do this, so let me remove this for a moment and then try to compile it. Which number was this? 6. We will get an error again. It says expected type string got any instead. So this is just where we say we need to help BOA sometimes in understanding, like, hey, we know that if we call this function, a string will be returned. So we use a cast it just from a regular typing library. I cast it to a string, and we say whatever is in greetings is a string. If we now try to compile it, it will work. Okay, 1 second, let me see. What is the function? Okay, so I see some questions popping up in my DM. I will wait with answering them until I've finished this. So the idea is that we leave at least 10 minutes for answering questions. If it does not fit in there, I will be on Discord to answer any remaining questions that did not fit in the scheduled hours. So do not worry if your question did not get addressed. Either post it again in Discord or I will answer it over there in the Python channel. Going back to the contract, so as you can see, this, I guess this is fine if you want to call a contract like once. But what if you want to call multiple functions on a contract, or you want to call the same function multiple times? Now we have a bit of a nicer way of doing this. We can actually make a wrapper for smart contracts that exist on the chain. So in a way this looks like is we create a class, we can name it anything we want, and we add an annotation specifying the script hash of the contract. And the script hash is just basically the unique identifier of the contract. And with that, we can add methods. They have to be static methods as far as I know, for this feature to work. And then we say, well, under the function hello stranger, we know it takes a name as a string, and we know it returns a string. And now we can use it in another way. We can call this directly. Say hello stranger. And the thing is, because we have annotated it here, we don't need to do the casting here. So this is a nicer way of interacting with other smart contracts, especially if you're going to do it multiple times. Or if you have a smart contract, say, for example, you created a decentralized exchange, you might want to make this kind of wrapper available for others to consume, for other smart contracts that might want to use your DEX. At the end, I will actually tell you of a tool which can do this automatically for you. So you can give it based on a contract hash or a manifest, it can generate like this whole class for you for all the supported languages on Neo. But more on this at the end. So this is calling other smart contracts, and this can be really useful because again, storage costs gas. So if you can reuse functions from other contracts that you know, then you basically save yourself development time. But also not just development time, but also money, because you don't have to pay for the storage that holds the logic for the functions that you need. So that's a nice way of reusing or allowing you to reuse code. Then another feature, metadata. So if you remember from in the beginning, I showed you when we compile, we generate not just a NEF file, like a new executable format, but also a manifest. And in this manifest, it has several fields. Let's see if I can show you one of the manifests. For example, well, if I do not specify anything, the default will be the name of the file. There's an ABI. This is mostly for the blockchain to interpret. Actually, everything is, but there's some interesting stuff here. Usually the supported standards, features. But let's just look at filling this in. So this contract is pretty much the same as the very first contract we looked at. And we can add standards here, or we can add metadata, for example, the author, an email, a description, restrictions of what other contracts it is allowed to call or not. Or, for example, supported standards, like, which is a list. For example, we say this contract supports NEP 17. And a cool feature of, for example, adding this supported standards, one, your block explorers will know that this is a NEP 17 contract. It can show you additional information. The other thing is BOA, based on what's in this list, will actually check if you implemented all functions required to adhere to the standard. So if we now try to compile this, BOA compile. I forgot the number again. 7. This is number 7. If we try to compile, say, hey, we are missing the symbol method, which returns a string, which is, if you look at the proposals, so these are the methods. So this is the NEP 17 standard, and these are the methods that should be there. It says this is the method symbol, and it must have return type of string. There's no parameters. So BOA will help you make sure that if you plan to write like an app17 contract or an app11 contract, that at least all the functions required by the standard exist and have the right signature, like the function signature. Of course, if you then implement a body that does something completely different, okay, that goes too far to start analyzing, but at least the basics of trying to help you out in making sure that everything that needs to be there is there, Boa's got you covered. I think that's a nice feature. There's more like add a group, like permissions. So this is a little bit too much to go into because I see I have only 5 minutes left. And I'd rather show you a couple of other features. So let's quickly go back. So this is something you might want to look into after the workshop, and you can always ask questions on Discord. If a feature is not properly described, file an issue and ask the questions, and we will try to help you. Two important functions that should be of interest of you are deploy and update. So the deploy function is a function with this specific signature that you can add to your contract. And what you can use it for example, is like a first time initialization. Say you want to destroy it, you want to set up basic parameters. Now, the way this works is the actor or the user will call a native contract. So a contract that's built into the NEO blockchain called contract management. And so it calls a function called deploy, and it must specify the NEF file, the manifest, and data is optional. And this data, so the contract management will make sure that the NEF is valid, the manifest is valid. It will store it to the chain, and then as a last step, kind of like a callback, it will call the _ deploy function on the actual smart contract that is deployed, which allows you to do initialization or whatever you want to do at that point. And the thing that is being passed on, which is its data, and you can put anything in there. You can put a string, you can identify, you can tell who is the new owner. That is all up to you. And the second argument is a flag telling you if this function is called based on a first time deploy or based on a contract update. Now, the other side of deploy is an update. So you've deployed your contract and you find an issue with the contract, or you want to add new features. There's a way to update your contract without your users requiring to change the script hash. So if you update your contract, the name cannot change. That's one of the requirements. And the script hash will also not change. So that's nice, because I think it was new too. One of the downside is that if you update your contract, now you need to tell everybody, it's like, hey, do not use the old contract, but use the new one. Here's the new address to use. And that's not very convenient. But the way update works is slightly different. So update actually starts at your own contract. So you need to implement an update function. It is up to you what you put in there, but generally, I think you want to have the same signature as before. You take a new executable file, a manifest, and optional data. Your contract then has to call the management contract. And the last step of the management contract again is calling your _ deploy, but this time the isUpdate parameter is set to true. So now, if there's for whatever reason you want to do something on update, for example, you want to reset all your storages, you can do that. I think those, let's see, those are pretty much the main features. I mean, there's a whole lot more. There's native contracts that exist. For the majority, like said before, if you go to Web3 built-in, most of the interesting stuff is here. I would even say most of it is under interop. So this is where, for example, there's a standard library, and well, let's see what it has. It's base 58, encoding and decoding base 64, binary serialization, deserialization to store a certain set of data. Please have a look and explore what is out there. There's also, like in what we showed before, in calling contracts. For example, if I go to Web3 in the native contract, there is pre-made wrappers, like this wrapper. There's pre-made wrappers for the native contracts. For example, let's say we have gas, and there's already gas transfer that's implemented, or gas symbol, balance of decimals. All this stuff is already built in, and the same holds for other contracts. So these are like most of the building blocks. I think with this you can get really far in your contract. If not, as shown before, go to the Neoboa GitHub repo, like Neoboa under Boa test examples. There's full-fledged examples here, like an AMM, ICO, NEP17, NEP11, Wrap Neo. They're big. They're all documented, and they should get you very far. However, one slightly off topic, but I wanted to address this specifically, is development flow. What I've seen a lot of people do is they use testnet as their main development environment. I would like, what I think is a recommended development flow is develop against a local chain. We have a tool called Neo Express. It can, like in one command, you basically type Neo Express create, and you have a local chain running, like a single node local chain. You have infinite funds, and that is one of the advantages. You don't have to ask anyone. It's like, hey, I want to test my smart contract. Oh, I found out that it doesn't work, and I please have new gas so I can deploy with a fix and do this 10, 50, I don't know how many times you need over and over again. So please start with local chain first. It will make your life easier. You can also reset the local chain. Like the testnet, you probably first have to sync it for half an hour, kind of depending also on your internet connection. All this stuff, no need. Everything is local. You don't even need internet. So start there, local chain, develop your contract. Now, once your contract is working as expected, then go to testnet, deploy there. Now you can invite other people for testing, for example. And if everything works as expected, you can pull the trigger and deploy to mainnet. That would be my recommended flow. And it also keeps testnet smaller and easier to sync up in the future, etc., etc. Lastly, some of the useful tools. So CPM is one of the tools by COZ. It is kind of like, for those familiar with JavaScript, TypeScript, it's kind of like NPM. I mean, it is not the repository itself, but it has the capability of pooling smart contracts from mainnet, from testnet into your local environment, like a complete duplicate of the network, but only those that you need. So, for example, you want to develop a smart contract that interacts with two or three smart contracts that currently live on mainnet. So the way to do this, you can create it's called CPM JSON. It's pretty much like a package JSON in NPM. You insert the script hashes, you say download or run. It will completely clone these two contracts to your local environment, and now you have a development environment that can pretty much simulate everything you need before going live. The other thing that it does, which I touched on shortly, is that CPM has the capability of generating these SDKs. So you give it a smart contract hash, it will download the manifest, and then it can generate SDKs for any language that we support on the Neo blockchain. It is so Go, Python, C#, Java, and that is useful. For example, again, if you want to expose an SDK for your customers, or for those who want to just work with your smart contract. The second is NeoMamba. So this is the other part of COZ's Python tools. So this is more the front end or the off-chain part, which allows you to interact with the blockchain, interact with your smart contracts. So you have a look at it. And finally, Neo Debugger, which we already saw. It is a VS Code extension to debug smart contracts. Unfortunately, it currently only works on VS Code. So for anyone that wants to have a good chance in a hackathon, please make one for PyCharm. And you will make me at least very happy, because the JetBrains Studio is my preferred tool of choice. Lastly, which we did not cover on, it's testing. Testing. There are some testing facilities in NeoBOA. They are not up to standard with what we want it to be. So just over a week ago, we released BOA 1.0. The testing facilities that are there currently have been mostly used only internally. It is on our current list to work on to give you a more like a nice way of testing, kind of like unit test, like your regular unit test where you create a test case, you can call a smart contract, you can assert the return values, that kind of stuff, have code coverage. So keep an eye out for that in the future. It is currently not there. If you want to know what test features are available, please have a look at the current BOA documentation, but be aware that it's going to be revamped very soon. So that is it for the presentation. I will have a look at the question list now.
Yeah. I think the first question is what happened if I use a function that's not in the subset of Python supported by BOA? Do you have some sort of meaningful error messages? Hi, Eric. Eric, can you hear me?
Eric, you're muted.
Oh, okay.
Oh, sorry for that. I tried to remove the window and I accidentally muted myself. You should get a compile error. So if you're using a function that it doesn't know, it will fail in compiling. And let me double check that with Mirella that this is the case. Or are there situations where BOA will not fail to compile for a function it doesn't support? I don't think so.
No,
right?
it will fail either on import error if we're trying to import a package that it's not supported, or as a method not found error in case of built-in methods that are not supported.
Okay. So method not found. That's basically what you're looking for if it's not supported.
Okay.
So this will all be during compile time. So that is the only thing. I mean, you got to run a compile to know whether it works. And also, I mean, if you use the debugger, you can pretty quickly find out if even if you got it to compile and it doesn't work, the debugger should help you, and please report an issue if that ever happens. I don't think I've seen it happen before, but you never know. Another question: what if there are multiple owners? Does CheckWitness support multisig? Yes, it does. I mean, and the multiple owners. So one of the, I mean, if a multi-signature is basically still one witness, but it's signed by multiple owners into a single witness. But you can even add groups. You can add other smart contracts that are allowed. Please have a look at the article by NSPCC, because there's a lot of details and options available there to, well, pretty much do any situation you can think of. Can you point us to an audit PDF from a BOA smart-based contract? Just that people see the usual issues coming from an audit process. Good question. I don't know of such a report, but I can ask a company that, so one of the, I can ask Red4Sec. So Red4Sec, one of their guys is a core developer for Neo as well. So Red4Sec is a security company. They often do smart contract audits. I can ask them if they have a report that can be shared publicly, because that's of course the question as well. If whoever paid for the audit is willing to share the results publicly. Those are the 3 questions I currently see.
Okay, I think that's all the questions today, and I think this is the end of today's workshop. Do you have some words, Eric?
Like I said before, if at some point you have questions or you run into issues, and we are on the Neo Discord in the Python channel, but you can also come to the COZ Discord. You can find our website is coz.io. There's a link to Discord over there as well, and we will try to help you.
Okay, I think
thank you for your time.
This workshop, you can send me the related links in this workshop, and I will put it in the description of the video.
Yep.
Okay. Thank you.
Very good.
Thank you all, and have a nice day.